The next reagent that we are going to study is trimethyl silyl iodide. Generally, we can call that to be TMS, trimethyl silyl iodide. Sometimes it is also called as TMSI, trimethyl silyl iodide. It's a very useful compound for which is having a lot of applications. This is the compound structure trimethyl silyl iodide. Now we are going to study in the general way of trimethyl silyl halides. We're going to study in general trimethyl silyl halides. Okay, so let us see first of all, we're going to see the preparation of the compounds. Okay, so we'll start with silicon tetrachloride, SiCl4. In reaction with 3 molecules of the Grignard reagent, methyl magnesium bromide will be getting CH3 thrice Si CH3 thrice Si chloride. Okay, so if you got, let's substitute this by chlorine itself to be able to understand the reaction. Here is CH3, this compound is formed. Okay, and the compound will be giving you okay, magnesium chloride will be formed. So we are not interested in byproduct, so we are not interested in writing that. This is a compound. Okay, this compound, trimethyl silyl iodide, chloride, you can easily undergo halogen exchange. For example, if you treat the compound with lithium iodide in chloroform, there will be exchange of halogens. Chlorine will be replaced by iodine. It will be getting CH3 thrice S silicon iodide plus lithium chloride is formed. So we can make the compound trimethyl silyl iodide here. Another way of preparing the compound is that this compound CH3 thrice Si, trimethyl silyl, again there will be SCH3 thrice. It is called hexamethyl disilane. It is called hexamethyl disilane. This compound on treatment with iodine in presence of around 25 to 60 degrees Celsius, we'll be getting 2 molecules. So there will be adding here, there will be adding here, there will be 2 molecules of trimethyl silyl iodide formed. Okay, this is how we can make trimethyl silyl iodide. There are 2 examples. You can make from trimethyl silyl chlorides, and also we can make from hexamethyl disilane. First synthesis, so this is second preparation. Now we are going to see the different uses. We're going to see the different uses of trimethyl silyl. It's having very important applications. Okay, the first thing is that this is used as a nucleophilic reagent. Is used as a nucleophilic reagent. For example, this is an ether. Okay, this ether on treatment with trimethyl silyl iodide is nucleophilic in nature. Therefore, oxygen is having 2 lone pairs to add to the silicon. Okay, as a result of that, it forms an adduct. O R, there's a plus here. There will be SiCH3 thrice And this bond shift towards here, and it forms an iodide salt. Okay, now what happens is that this will go like this. Okay, so we'll be getting R plus will be there. This R plus and Cl minus will go out as RCl, and it forms the compound R. What's left? R, O, and O, and this is left. Trimethylsilane is left. RO, TMS. So this can be used for the cleavage of ethers. You know that generally ethers are stable compounds, we cannot cleave them. Ethers can be cleaved by using this reagent, thymethylsilyl iodide. Similarly, another example, I'm going to give you another example. The tetrahydrofuran, this compound on treatment with TMS iodide will give you this compound. This compound. Now, the second application is that it is used to cleave cyclic ethers or epoxides. For example, this is a cyclic ether. Okay, there will be two lone pairs in the oxygen atom. There is TMS iodide. Lone pair adds to the silicon and iodine is gone out. So it will be forming this adduct plus here. There will be TMS and there will be I minus. Now what can happen is that this cleaves, the bond cleaves and it forms TMS. And here will be iodine coming. Okay, this is another example. We can use to cleave the cyclic ethers or epoxides. So we have seen that we can use to cleave ethers, and the second one is that it can be used to cleave cyclic ethers. Next one is that it is used to react with esters. You can react with esters. This can react with esters. With esters, the reaction is like this. This is an ester. This compound bond treatment with TMS chloride had two long pairs in the oxygen atom. It adds TMS iodide. Okay, it will be going like this. As a result of that, it forms RC double bond O. There will be R plus there will be TMS and I minus. Now, this gives to this place, here as a result of that, there will be O is there, O TMS is formed, plus RI is formed. Later, this can be hydrolyzed to form RCOOH. So we can hydrolyze esters using TMS iodide. Okay, second application of TMS is that it is used for nucleophilic addition. It is used for nucleophilic addition reaction. It is used for nucleophilic addition reaction. Okay. For example, earlier we have seen that it is actually, the earlier example we have seen it's a nucleophilic reagent. It acts as a nucleophile. Next example, you can see that it is used for nucleophilic addition. So there is a aldehyde here. This aldehyde on treatment with CH3 trisilicon iodide. There are two lone pairs here. Lone pair adds 2 and it adds like that the same phase. Now there will be a O plus double bond here. There will be TMS here. There is a hydrogen here and there is I minus. Now the I minus will attack to this side and go like this. And as a result of that, we'll be getting ROTMS I. So here you can see that there is nucleophilic addition. So the TMS adds to the carbonyl. It's actually called nucleophilic addition reaction. Okay, but in the case of this compound, alpha beta unsaturated compounds, alpha beta unsaturated compounds. Okay, so if you use TMS iodide, addition will take place in two ways. One thing is that the first product, as we expect, we get this compound or TMS adding here and R2 here, this R1 here. It's actually 1,2 addition. But we can see that after this, it can also add this place. So that I have to write the mechanism here. Double bond O, TMS is R2 plus. What can happen is that I minus can also attack the fourth position. Now the bond shifts like this and it go like that. In that case, we'll be getting R1 or TMS R2 is formed. Okay, so it is 1,4 addition. This 1,4 addition is happening. It is the second example. Application. Third application is using as protection group, protecting group. We can call that to be a protection group. We can call that to be protection of alcohols. Okay, protection of alcohols. This topic, we will discuss this application. We will discuss not now. We will discuss during the study of protecting groups after 1 or 2 lectures. So these are some of the applications of trimethyl iodide in organic synthesis. Thank you.